Welcome to this video on the topic of algebra. In this video, we're going to have a look at how we can solve algebraic equations. Now, an equation is a mathematical statement that contains an equal sign. Consider 3x plus 2 equals 11. This is an equation because we have the equal sign over here. The meaning of the equal sign is that both sides of the expression here represent the same thing. In other words, 3x plus 2 is the same as 11, or 11 is the same as 3x plus 2. As such, both expressions carry the same value. Now, this condition here is what allows us to be able to solve algebraic equations. If we know that both sides of this equation are equal to 11, what this means is that by unwinding all of the items around the unknown, we're able to determine what the value of this unknown needs to be such that both sides are 11. Thus, the value of the unknown variable may be solved by rearranging the equation. Let's have a look at an example of how this is done. In example 1 over here, we're going to solve for the unknown. The equation on hand is 3x plus 2 equals 11, the same one as up here. To solve for the value of the unknown here, what we're first going to do is we're going to understand how the left hand side here is put together, and then we're going to reverse it. So firstly, what I'm going to do is I'm going to draw a flowchart, and then I'm going to unwind this equation. Start off by writing 3x plus 2, and that's my left hand side. Now I'm going to build a flowchart. I start off by writing x, and then I'm going to turn my x into 3x. After which I turn my 3x into 3x plus 2. Understanding how I put this together, firstly I multiplied by 3, then I added 2. Now this is how the expression was put together on the left. What I'm then going to do is I'm going to have a look at how I can reverse this. Looking at this, we have a flowchart that shows how this expression is built. What we want to do is we want to understand how we can unpack this expression or unwind this expression. To do this, I start from the right hand side of the flowchart and I look at the first operation. It was plus 2 here. So what I'm going to do is I'm going to reverse this, and rather than plussing 2, I'm going to subtract 2, because that will take 3x plus 2 back to 3x. And then to take 3x back to x, I'm going to divide by 3. So basically I'm doing the opposite to what I did at the top. Thus, what we end up with is a reverse flowchart of how to unwind the expression here. Now, using the information gathered from this flowchart over here, I'm going to rearrange this equation such that it's going to be x equals something. Carrying this out, I rewrite my equation again. 3x plus 2 equals 11. And now I'm going to start unwinding everything. I see on my flowchart over here, to change my 3x plus 2 back to 3x, I have to subtract 2. So what I'm going to do is I'm going to subtract 2 from both sides of the equation. On the right hand side, I have 11 take 2, and that's going to take me back to 9. On the left hand side, I have 3x plus 2, which is going to mean I'm going to get 3x, and then the 2 is going to turn into 0. Simplifying this, I get 3x equals 9. Now, I'm at 3x, and I want to take this back to x. To do this, I have to divide by 3. To do this, I'm going to divide both sides of my equation by 3. And thus, the 3 is now gone on the left because I'm now at x, and 9 divided by 3 is 3. And therefore, because we've narrowed x down to what it is, we simply say x equals 3. And therefore, what we've done is we've been able to solve the value of x that will make this left hand side here equal 11. Now, checking that this is indeed true, what we can do is we can say 3x plus 2 equals 11. then I can say something of the likes of let x equal 3. Then whenever I see an x, what I'm going to do is I'm going to turn it into 3. So it's going to be 3 times 3. Solving this, that should be 11. We're going to get 3 times 3 is 9 plus 2. And then 9 plus 2 is 11. And therefore what we see is that 11 indeed equals 11. Alright, example 1. Moving on to B. 6x minus 4 equals 8. What we're going to do is, once again, we're going to get our left hand side here. We're going to turn it into a flowchart and then reverse the operations. Starting off on the left hand side, we have 6x take 4. So starting from the variable, I have x. I'm then going to turn it into 6x. And then I'm going to turn it into 6x take 4. Constructing the flowchart. Building it forward, we had times 6 minus 4. And therefore, going in reverse, we're going to have the opposite of take 4 is plus 4. And the opposite of times 6 is going to be divide by 6. Now, using this flowchart, we understand how we can unbuild our expression here. Let's use these operations to unwind all of the items around x and therefore solve for x. Carrying this out, I'm going to write out 6x minus 4 still equal to 8. Then first operation is I'm going to plus 4 to both sides of my equation. The result of this will be 8 plus 4 is 12. But the minus 4 and the plus 4 will cancel, so we'll get 0 there, 6x there. Simplifying this out, 6x is equal to 12. Now, removing the 6x and changing it back to x, I simply divide both sides by 6. This will yield x on the left, and then 12 divided by 6 is 2. And therefore, the value for this is x equals 2. Verifying that this is indeed correct, what I'm going to do is I can simply write out 6x minus 4 equals 8. I can communicate what I'm doing here, so I'll say let x equal 2. Then whenever I see x, I'm going to rewrite it as 2. Evaluating this, 8 on the right, and then we have 12 take 4 on the left. 12 take away 4 is 8, so therefore 8 is equal to 8, which therefore means that we've got the right value of x. We have verified. Moving on, we see a slightly more vexing question, x over 3 minus 5 equals 11. To carry out this question, what we're going to do is exactly what we've been doing leading up to this. I'm going to start off by building the expression. First thing I'm going to do is, looking at the left over here, I ask myself, how do I build this up? Well, I'm going to start with x. And then from x, I'm going to say x over 3. And then from there, it's going to be x over 3, take away 5. Turning this into the flowchart, we first divide by 3. And then we take 5. Reversing this up, we take 5, so we add 5, and we divide it by 3. So what that means is we need to times by 3. And therefore what we've done is we've built the flowchart that will show us how to unwind the expression on the left here to solve for x. Now, solving for x, I'm simply going to write out the equation one more time. And then, looking at my first reverse operation, I'm going to plus 5. So I'll plus 5 to both sides. On the right hand side, I've got 7 plus 5, which is 12. And on the left hand side, I've got a 0 and a x over 3. And that's going to simplify down to x over 3 is equal to 12. Now, transforming this x over 3 back into x, I can see that I'm going to times by 3. So I'll multiply both sides by 3, and therefore what that yields is x on the left, and 12 3s are going to be 36. So therefore what we can see is that the value for x is. Checking that this is indeed the correct answer, what we can do is we can verify. Alright, moving down to D. In D we have an equation that's presented in a different form. Difference being in that our x is usually on the far left, now it's over here. So let's see if we can solve this using the exact same method we've been using all along here. Carrying this out, I look on the left hand side and I see we've got 7 plus 5x. Now starting with x, what I first want to do is I want to turn it into 5x. So I've got x over here, I'll turn it into 5x like so, and then I've got this addition of 7, so I'm going to go 5x plus 7. Constructing the flowchart, I can see to build x up to get 5x plus 7, I times by 5 and then I add 7. So to take 5x plus 7 back to x, I'm first going to subtract 7 and then divide by 5. Solving, I rewrite out 7 plus 5x equals 52. I'm going to go for my first reverse operation, which is to take 7 from both sides. 52 take away 7 is going to be 45. Got 0 plus 5x. I'm then going to rewrite that as 5x equals 45. Removing the 5 from the x, so changing 5x back to x, I divide by 5. This will give me the value for x, such that x is equal to 45 divided by 5 is 9. So x in this case is equal to 9. Checking that this is indeed the correct result. Alright, final one and trickiest of them all. We have 3x over 4 plus 1 equals 13. What we're going to do to solve this is exactly what we did with all the other ones, in that we are going to construct a flowchart. Now, constructing the flowchart for this, what we're going to do is we're going to have a look at how we put together the left hand side. Building the flowchart, we first start off with x. From x, we're going to turn it into x divided by 4. Then we're going to turn it into 3x divided by 4. And then finally, we're going to turn this into 3x divided by 4 plus 1. Putting the flowchart together, this is going to be divide by 4 times by 3, add 1. And therefore, reversing this, we're going to subtract 1, divide by 3, and finally multiply by 4, thus yielding the operations we need to do to solve for x here. Carrying this out, we are going to go 3x over 4 plus 1 equals 13. I'm now going to take 1 from both sides. This will give me 12 on the left. It will eliminate my plus 1, and therefore I end up with 3x over 4 equals 12. Next step is I'm going to divide both sides by 3. This will give me x over 4, and 12 divided by 3 is 4. And to finish this off, I am going to multiply both sides by 4, which will yield the result of x is equal to 16. Checking that this is indeed the correct answer. So in summary, what we had a look at in this video was how we can solve for unknowns within algebraic equations. To do this, we first look at the unknown on the left hand side here, we first construct a flowchart to see how the expression's built, then we reverse the operations to discover how it's unwound, and then we unwind the expression on the left to reveal the value of x.